Good morning all. Today we'll be discussing about the problems of hydrograph. So first go through the question. Following is the data of a storm of 3-hour duration with a drainage area 30 kilometer square. Determine how many centimeters of rainfall excess does the storm hydrograph represent. So these are the data given. Then date and time it is given, then ordinate of storm hydrograph it is given, and base flow also given. So first we'll look at the question. That is, it's a 3-hour duration data is given, and drainage area it is 30 kilometer square. We have to find out what is the rainfall excess in centimeter. Here the storm hydrograph ordinates are given. We have to calculate the direct runoff depth. So what is the equation to calculate direct runoff depth? We know the equation 0.36 sigma O T divided by A, where sigma O represent the sum of ordinates of direct runoff, ordinates, and T represent the time in hours, A represent the area in kilometers square. So time and area of area also known. We have to calculate sigma O. How to calculate sigma O? In this case, here we have the storm hydrograph. Okay, we have the storm hydrograph. Then the base flow, it is also given in the question. So in order to calculate the direct runoff hydrograph, first you have to remove the base flow from the storm hydrograph. So we'll get the direct runoff hydrograph. So these are the different ordinates, O1, O2, etc., ON. Then you have to find out sum of these ordinates, that is O1 plus etc. ON. So you'll get the value of sigma O. So what is the first step? From the storm hydrograph, you have to deduct the base flow. So you'll get the direct runoff hydrograph. Then find out the sum of ordinates. Then substitute this value here. You will get the direct runoff depth. So we'll start the problem. This is the problem. So ordinate of storm hydrograph it is given. Next one, we have to calculate direct runoff ordinates. So that is equal to 14 minus 14. That is, from storm hydrograph we are deducting the base flow. Here it will be 25 minus 12. Find out each value, and then finally you will get the sum of ordinates here. Take the sum of values in this column. So this is the final values. Here you will be getting 166. The next one, it is direct runoff depth. That is a value which we have to find out. Then here sigma O, it is 166, and it is time, it is 3 hours, and area it is given the question as 30 kilometer square. And this formula sigma O we have to substitute in meter cube per second, and time in hours, and area in kilometer square. So the value, calculate the value, you will be getting it as 5.98 centimeters. Next question. The observed flows from a storm of 6-hour duration are as given below. Assuming a constant base flow of 15 cumex, derive a 6-hour unit hydrograph. The area of the drainage basin of the storm is 425 kilometers square. So these are the data given. Okay. this represent the data, and then next we'll go through the question. What we have to do? We have to derive a 6-hour hydrograph. So we have to get the 6-hour unit hydrograph. Okay, and here observed flows, that is ordinates of storm hydrograph are given. Then it is given the base flow as 15 cumecs and area of the basin also given. So in order to derive a unit hydrograph, we have here the storm hydrograph that includes both base flow and direct runoff. Okay, direct runoff. So first you deduct the base flow. So you will get, what you will get? You will get the direct runoff hydrograph. These are the ordinates, O1, O2, ON, etc. represent the ordinates of direct runoff hydrograph. Then finally you have to find out the unit hydrograph. How to find out unit hydrograph? For that one, you have to find out the direct runoff depth. Next step, you have to find out direct runoff depth. How to find out direct runoff depth? For that, we have the equation 0.36 sigma O T divided by A, where sigma O represents the sum of these ordinates. Sum of these ordinates. Then T represent the time in hours, area it is given. So after getting this value, each ordinate divided by this direct runoff depth, you will get the ordinates of unit hydrograph U1, U2, etc. So each ordinate, O1 divided by direct runoff depth, O2 divided by direct runoff depth, ON divided by direct runoff depth represent the ordinates of unit hydrograph. Okay, so next we'll solve the question. So these are the data given. So this represents the storm hydrograph ordinates. Then next one, we have to find out the direct runoff hydrograph, ordinates of direct runoff. So this represents direct runoff ordinates. Next, so how to find out the direct runoff ordinates? For that one, we have to deduct the base flow. We have to deduct the base flow, that is equal to 15 minus, in the question it is given the base flow, it is 15 cumecs. So 15, here it will be 117.8 minus 15, here it will be 260.7 minus 15. Find out the value of direct runoff ordinates. Then next one, you have to find out the ordinate of unit hydrograph. For that one, you have to calculate the direct runoff depth. Okay, direct runoff depth. So in order to calculate the direct runoff depth, we have this equation. For that one, first you have to find out the value of sigma O. So from here you will get the value of sigma O. Take the sum of all these values, you will get the value of sum of ordinates. So now we got the value of sigma O as 990.8 into T, it is 6 hours, divided by area, it is 425. So we will be getting 5.04. So the next one, ordinate of unit hydrograph. How to get the ordinate of unit hydrograph? This divided by direct runoff depth. Direct runoff depth, that is, this represents 0 divided by 5.04. This is equal to 102.8 divided by 5.04, like that find out the value. So this represents the ordinate of unit hydrograph. Next, coming to the third question, first go through the question. Compute and plot the storm hydrograph resulting from a 4-hour storm with a rainfall of 40 mm. Assume an initial loss of 5 mm. Infiltration index it is 2.5 mm per hour. Base flow it is 15 cumex. The ordinate of 4-hour unit hydrograph are given below. These are the ordinates. Okay. So first we'll go through the question. Here unit hydrograph it is given. And we have to plot the storm hydrograph. We have to get storm hydrograph. So the reverse procedure, here we know the unit hydrograph with ordinates u1, u2, etc. un. Okay, from that one you have to develop the storm hydrograph. Storm hydrograph. So how to calculate? From this unit hydrograph, first you have to calculate the direct runoff hydrograph. We have to calculate the direct runoff hydrograph with ordinates O1, O2, etc. ON. Okay, in order to get that one, how to get, normally how we are getting the unit hydrograph ordinate? We have to divide this ordinates using direct runoff depth. Okay, direct runoff depth. So next step we have to calculate direct runoff depth. Direct runoff depth. Okay. So the equation to calculate direct runoff depth it is 0.36 sigma O T divided by A. That is if the value sigma O is not. But here we have to calculate the ordinates. So try to find out direct runoff depth. First go through the question and try to find out the value of direct runoff depth. And in the question it is given that the total rainfall it is 40 mm and an initial loss of 5 mm and infiltration index it is 2.5 mm per hour. So you will get the direct runoff depth from this given data, that is direct runoff depth is equal to excess rainfall, total rainfall it is 40 minus there is an initial loss 5 and there is an infiltration index value it is 2.5 mm per hour into what is the total. So for per hour it is 2.5 mm. There are the duration of our rainfall it is 4 hours. So into 4. So you will be getting as 25 mm. So we have to take this value in centimeter. So the excess rainfall in centimeter it is 2.5. The next procedure we need to get the value of O1. How to get O1, O2, etc. O1, O2, etc. ON. Multiply this ordinate U1, U2, UN with this direct runoff depth. You will get the ordinates O1, O2, ON. Then next step we have to form the storm hydrograph. So this represents only the direct runoff. This represents only the direct runoff. We have to get the storm hydrograph that includes both direct runoff and base flow. So add base flow to this ordinates. Okay, add base flow to this ordinates, you will get the storm hydrograph. So this is a procedure. So we'll solve that one. Ordinates of direct runoff hydrograph, that is equal to 0 into what is the depth of runoff, it is 2.5. So this is 115 into 2.5. This is 370 into 2.5. Then base flow, in the question it is given as 15. So throughout it is 15. Then total discharge, that is equal to direct runoff plus base flow. Direct runoff plus base flow. Calculate the value. So finally you will be getting this as the total discharge. And here you have to plot the storm hydrograph. So x axis represent time and y axis represent the discharge, the total discharge. So this represent y axis, this represent x axis. Draw the hydrograph by taking a proper scale. Okay. The last question, find the ordinates of flood hydrograph resulting from a storm with rainfall of 2.5, 6.85 and 3.75 centimeter each during successive 3 hours. The ordinates of 3-hour unit hydrograph are given below. Assume an initial loss of 5 mm. Infiltration index is equal to 2.5 mm per hour and base flow of 12 cumex. So here you have to calculate, find out the ordinates of flood hydrograph. That is, we have to draw the, we have to calculate the ordinates of storm hydrograph. And it is given in this question, there are 3 rainfall values, that is excess rainfall resulting from 3 rainfall values, that is 2.5 centimeter, then 6.85 and 3.75 centimeter in successive 3 hours. That is, in the first 3 hours there is a rainfall of 2.5 centimeter. After that, next 3 hours the rainfall it is 6.85. Next we are getting a 3.75 centimeter rainfall. Then the ordinates of unit hydrograph it is given. Then the initial loss it is given as 5 mm. That is, the initial loss is met by the from the first rainfall itself. Then infiltration index it is 2.5 mm per hour and base flow. So we will start the question. Okay, these are the data given, ordinate of unit hydrograph. So first one, you have to find out rainfall excess. Okay, rainfall excess that is in the first 3 hours. So it is given 2.5 centimeter as rainfall. So 2.5, this is the first rainfall. So there will be an initial loss. So this represents the rainfall minus initial loss minus infiltration. Okay, here it is 2.5 rainfall, then 0.5 5 mm it is given as, convert that into centimeter, 0.5 centimeter as initial losses, and infiltration it is 2.5 mm per hour, converting that into centimeter, hour it is 3, duration it is 3 hours. So we will be getting a rainfall excess of 1.25 centimeter. And if you consider the rainfall excess for second 3 hours, it is 6.85 minus infiltration. There won't be any initial loss, that is already met in the first rainfall itself. So it is 6.25 minus infiltration loss. So you will be getting it as 6.1 centimeter. Then the rainfall excess for the third 3 hours, it is 3.75 minus infiltration loss. So you will be getting 3 centimeters. Okay. And the previous question, there is only one rainfall, but here we have 3 rainfall values. So draw the table like this. And the first two columns represent the data and the question. Then we have rainfall excess that we have calculated in the third column. And the next one, we are calculating a runoff from rainfall excess during successive duration of 3 hours. What is the runoff excess? Okay, that is a direct runoff value in each 3 hours, because here we have 3 rainfall data. So in each 3 hours the runoff value is different. So I am considering in the first 3 hours there is an excess rainfall of 1.25. So the ordinate of unit hydrograph, it is given. So in order to calculate the direct runoff hydrograph, we have to multiply the excess rainfall, or this we can call it as direct runoff depth. Direct runoff depth with the ordinate of unit hydrograph. So this value will be 0 into 1.25. Here it will be 115 into 1.25. Here it will be 370 into 1.25, 510 into 1.25. Like that, find out all the values. Okay, so this is the excess rainfall, this is a runoff ordinates due to rainfall excess of 1.25 centimeter. Then next you consider there is another runoff value, rainfall excess, it is 6.1 centimeter. So what is the total flow in the river due to this 6.1 centimeter excess rainfall? So this 6.1 centimeter rainfall is happening in the next 3 hours. Okay, is happening in the next 3 hours. So you have to start from here. That is, at the starting of 6 hours the rainfall occurs. So here you have to start from the second column, I mean second row. So this will be equal to 0 into 6.1. Then next one, it is 115 into 6.1. Next it is 370 into 6.1. Then 510 into 6.1, like that. And here it will be 24 into 0 into 6.1. Here it is 12 into 6.1. Find out the value. Then next one, next 3 hours after in the third 3 hours, that is here, there is an excess rainfall of 3 centimeter. So what is the direct runoff ordinate due to this direct runoff depth, that is 3 centimeter excess rainfall. So when it will start? It will start during the hour 9. So you have to write from here, that will be 0 into 3. Next it is 115 into 3. It is 370 into 3. Here it is 510 into 3. Like that, calculate. So this will be 0 into 3. This will be 12 into 3. And next column, it is base flow. Base flow, it is constant and it is 12. So write down 12. So due to this excess rainfall, the runoff values in the river increases. So what is the total ordinates? You have to add all the values. That is, you have to add, say, take it as 1, this as 2, this as 3, and this as 4. So I am taking this as 5, so equal to 1 plus 2 plus 3 plus 4. You will get the total base ordinates of flood hydrograph. 1 plus 2 plus 1, 2, 3 represent the ordinate of hydrograph due to each rainfall. Okay, excess rainfall 1.25, another one it is 6.1, another one it is 3, and add all the values, you will get the ordinate of flood hydrograph. So this is the final value.